Reading through this problem, you can see they're giving us a function that they're telling us is twice differentiable, which just means the derivative exists twice. Then they're telling us some specific points, right? So we have a point on the graph. We've got the derivative value, which is the slope of the graph. And then we have the second derivative value, which is the concavity of the graph. And they want to know what is the value of the, notice keywords like approximation tell you something's a little off. When they don't want the exact value, you know you're doing something unique. So they want us to approximate this value using the line tangent to the graph at that specific point x equals 3. When you see that terminology going together, line tangent approximation, the proper English would call that a tangent line approximation. That's what we're doing here. The tangent line approximation is a formula that we have to memorize. So the tangent line approximation says f prime of x naught times x minus x naught plus f of x naught. So what this is this is an equation that's going to approximate your original function f of x. So what you need is those, just a couple of pieces. You need the derivative, you need the point on the graph, and then the x value from the point, and then the y value from the point. So we go and grab that data. Our x naught on this, the value that we care about, is going to be the 3 that they give us right here. So that means to fill this out, we need to find what is f prime of 3. Well, conveniently they gave us that up here. So f prime of 3 is 6. And then we need to know what is f of x naught, so f of 3. And again, they gave that to us at the beginning here, and so that equals 2. And that's all we need. So it's looking like we don't even need that second derivative data. So, you got to caution yourself, just because they give you that doesn't always mean you need all the information they give you. It's not always set in stone. So I start plugging in for my equation. I need my f prime of x naught values, so that's going to be this amount here, so that's going to be 6. That'll be times x minus my x naught value, which is 3. And then we're going to add to that f of x naught, which we got from the beginning of the problem. That was 2. So this now is our equation here for approximating what f of x is. F of x is approximately 6 times x minus 3 plus 2. And now that you have your approximation equation, now it's time to go back and find what they specifically wanted. So from us, they wanted f of 2.9. When you're using these, it's helpful, especially because you don't have a calculator, to go ahead and leave the equation without multiplying everything together. Because the idea behind a tangent line approximation is we're plugging in something close to this number, so that math should be easy to do. And if you went ahead and multiplied, distributed everything out on this step, you lose that advantage of the problem that there's simple math to do there. So don't multiply it out when you're doing a tangent line approximation. Because now I can see 2.9 minus 3, that's negative 0.1 plus 2. And again, you just got to be able to do this type of math, unfortunately, in your head, right? Because you don't have a calculator. 6 times 0.1, that's going to get us negative 0.6 plus 2. And then again, we just got to do this last bit of math in our head right here. So negative 0.6 plus 2 is going to give us 1.4. And so what we know is approximately f of 2.9 equals 1.4. So tangent line approximation, it's a formula. You got to have it memorized. If you do, problems like this, pretty straightforward. If you don't have it memorized, probably not going to remember it in the middle of the test. Thanks for watching my video. If you liked it, please click that like button and subscribe. And also share it with your friends and anyone else you know who might be crying about an upcoming AP Calc test. You can find more videos from me, more sample AP Calc questions, and my complete AP Calc study guide over at my website, apcalcprep.com. Have a great one.